3.6, inverses of functions. What an inverse of a function is. The inverse of a relation consisting of ordered pairs x, y is the set of all ordered pairs y, x. What's the only thing that happens? They switch. The x's become y's and the y's become x's. The domain of the inverse is the range of the original relation. The range of the inverse is now the domain. So the domains become the ranges become the domains. We're going to find an equation that is the inverse of y equals 3x minus 2. So just looking at this, graphing this, where do I start? Down 2. Go up 3, to the right 1, and then I take, board's offline, that's the first one. This is y equals 3x minus 2. I didn't do any, I have not found the inverse yet. What does the inverse do in general? The inverse in general does what? Switches the x's and y's. So for this, I'm going to take and switch the x's and y's. So y becomes x, x becomes y. Can you graph that as is? No, what do I have to do? I have to rearrange it into slope-intercept form. What do I need to do first? Add 2. So I have x plus 2 equals 3y. Divide everything by 3. So I have y equals. What does this mean right here? 1/3 x plus 2/3. This is the one tricky part a lot of you have a hard time with. Where do I start at? I go up 2/3. Where's 2/3 at? In between 1 and 0. I'm not going to look exactly if you're 2/3. It's in between, you're good enough. Now what do I need to do? Up 1, and then to the right 3. 1, 2, 3. And I'll draw my second one. That is what my graph looks like. Questions? That's it. I'm just showing you graphically how it looks. You're not going to have to graph all of them. Now, pulling in what we did last section, what I want you to do, a way to write the inverse is f negative 1. So when we're talking about functions, that's the inverse function of x when you have to the negative 1 power. I'm just going to call the inverse of f g of x. So here's f of x, here's g of x. I want you to find fog, and I want you to find goth. Did we notice anything? Did you find anything for fog and goth? All right. if I find fog, fog means I take G and put it into F. So I have 3 times 1/3 x plus 2/3 minus 2. Always simplify. Don't leave things like this. Go through as far as you can. What's 3 times 1/3? 1x, so it's just x. What's 3 times 2/3? Plus 2 minus 2. So I'm just left with x. Now finding Goff, I put f into g. So that means 1/3. There's an x, so I put in 3x minus 2 plus 2/3. Simplify this one. What's 1/3 times 3? Just so it's 1x. What's 1/3 times negative 2? Negative 2/3 plus 2/3. They cancel out. What am I left with? X. What did you notice? They're the same answer, and they're both equal to x. If you need to find out if two things are inverses of one another, find fog and Goff. To prove that two things are inverses of one another, find fog and Goff. These two look familiar, right? Isn't that problem right there? So proving that these two were inverses of one another, you can take fog and Goff. And that's pretty much what we just said. Since fog equals Goff, then they are inverses of one another. And they should both equal x. All right, I have f of x equals x squared plus 4x. We need to find, for some reason, this isn't showing up right. F of x equals x squared plus 4x. We're going to find the inverse of x. What's another word for f of x? What's the other thing we use? Y. So to find the inverse, we're going to make x equals y squared plus 4y. Now what I'm going to do is I'm going to set it equal to 0. So subtract the x over. So I have y squared plus 4y minus x is now equal to 0. Be okay with this step? How can I solve this problem? What's the first thing I should do to try to solve a problem like this? What is it called? This is called a quadratic because it's second power. Look, can I pull anything out? No. Can I factor it? No, there's an x here, and that messes things up. So I don't want to complete the square. A quadratic formula. Quadratic formula. Let's see. That's A is 1. That's B. C is negative x. It's negative x. This is y squared. This is y. The last term is always just a number. Here it's x. So I have y equals. Why is this one y equals instead of x equals? These ones are y squareds instead of x squareds. Negative b plus or minus the square root b squared minus 4 times a times c, all over 2 times a. Y equals negative 4 plus or minus the square root. What's 4 squared? 16. Negative 4 times 1 times negative x plus 4x all over 2. Bless you. Now this right here, it's hard to see what it is. I'm going to get out my calculator. If I graph this, how do I graph this in my calculator? Negative 4, actually I need to put parentheses, negative 4 plus square root 16 plus 4x, end parenthesis for the square root, end parenthesis for the top, divided by 2. Good. I have to do the exact same thing, but now subtraction in the middle. So parenthesis, negative 4 minus square root 16 plus 4x, and for the square root, and for the top, divided by 2. Questions there? Okay, I'm going to graph. That's the first one. That's the second one. Is this a function? Why not? Vertical line test. This fails the vertical line test. So this tells me this inverse is not a function. Do you understand what we did? We rearranged it. We solved it. When we graphed it, it's a sideways parabola. It fails the vertical line test. In order to be a function, it has to pass the vertical line test. It touches in more than one spot on the vertical line. If I take this graph, and I take a vertical line, we need to look, does it ever hit in more than one spot? It's always hitting more than one spot. It's not a function. Now, I want to show you something. This one here. I have f of x equals 0.7 x to the fifth plus 0.3 x to the fourth minus 0.2 x cubed plus 2x plus 0.5. We want to find the inverse of f. Now to find the inverse, okay, you don't have to write this down right now. What does it mean to do the inverse? Flip the x and y. You don't have to write this. x equals 0.7x, sorry, not x, y to the fifth plus 0.3 y to the fourth minus 0.2 y cubed plus 2y plus 0.5. Could you solve this one? Do you know of any way right now how to solve this? No. This one you can't because it's a quadratic. This one here, you can't rearrange for it. So I'm going to show you another way to do it. Take the original function, put it in your calculator. 0.7 x to the fifth plus 0.3 x to the fourth minus 0.2 x cubed plus 2x plus 0.5. When I graph this, this is how it looks. That's my original function right here. How do I know it's a function? It passes the vertical line test. Nowhere does it hit more than one spot. I know it looks like it does right here, but if I zoomed in, the line's more curved. It just, the way we're looking at it, it looks like it's a straight line. Now, I'm going to go back to this one. Do you remember what the original graph looked like? Or what the second graph looked like? It was a sideways parabola, right? If I go into the calculator, I'm going to turn this one off. X squared plus 4x. That's that original function. How did its inverse look? Okay, here's this function. It was sideways, right? You said it was like that. What's the only thing I did? I took the original graph and rotated it. What am I going to do with this to find the inverse? Take it and rotate it. Does this pass a vertical line test? Yes. So the inverse is a function. We can't necessarily find the equation for it, but the inverse is a function. Without taking your calculator and turning it sideways, how can I look at this graph and tell whether or not the inverse is a function? The vertical line tells me if the original function is a function, or the original graph is a function. What can I do instead of turning the calculator? Think of a horizontal line. If this passes a horizontal line test, there is an inverse. Going back to this one, there's my original graph. To tell if it's a function, the original one, that's not very vertical, it passes the vertical line test, right? But if I think horizontally, does it pass a horizontal line test? No, then the inverse is not a function. Find this one. Is the inverse a function? What do I need to use in order to solve this? As much as I can do is this. X equals y cubed minus 3y plus 1. Can I rearrange this one and solve it? Can I solve this one? No, it's cubed. We haven't worked with cubes yet. So now I just take in the calculator, and I type in x cubed minus 3x minus 1. I graph it. Here's my graph. To tell whether or not the inverse is a function, I use the horizontal line test. Does it pass a horizontal line test? No. So this right here, x equals y cubed minus 3y plus 1, is not a function, even though that's my inverse. Everything you can find an inverse, it's whether or not it's a function. Are we okay with this? If it's squared, it's just solving it algebraically, rearranging it. Some of them you can, some of them you can't. At least get as far as you can with this. This one we know right off the bat. I move the x over. I have y's and x's. This one here, I had y's all over the place. I don't know how to work with a fifth. This one here, I have y squared plus 4y. I know how to work with quadratics. Let me give it a try. If you get stuck, you get stuck. We can always work on that. Try this one. I get as far as I can algebraically. First thing I'm going to do is change the x's and the y's. So it's now x equals y to the fifth plus 1 cubed. What am I going to end up with here? What's my first term going to be? Y to the 15th power. Yeah, I'm not going to even try messing with a y to the 15th. I got that far. Grab my calculator. For the y equals, I type in x to the fifth plus 1, and all of that is cubed. Most likely your mistakes are going to be, I forgot a parenthesis, I forgot a number, something like that. I graph it. Looking at it, the horizontal test, what do you think? Yes. The only part that's a little bit questionable is right in here. But if I zoom in at that, right where I think there's a mistake, right there, right? If I trace, is it a straight line? Is it perfectly straight? No. So it passes the horizontal line test. The only time you have to worry is if it stays the same number when I hit trace. Make sure to hit trace and not just left and right. Because if I just, all right, zoom, just graph. And I just started moving the cursor left and right. Of course my y values are going to stay the same. Because all I'm doing is moving the cursor. You have to hit trace. And that traces the line. It's moving just a little bit. Because what? It went from 1 to 1.003. Small movement. Are we okay on inverses? Okay.